Welcome to Series and Stuff. I'm Steven.
And I'm Francis.
Many young people nowadays have no idea how to handle themselves when it comes to the fine art of series.
But that's okay. That is why we are here. For you. And you alone.
Today's topics we'll be covering are error-bound and estimation theorems. To help us with that is one of our many good friends, Joseph Luis Lagrange.
Mr. Lagrange, sir, I'm a high school student taking Calculus B.C. I know nothing about error-bound, and I have this test coming up, and if I fail, I get an F in the class. You are my last resort. Teach me the ways of calculus, please.
Of course, my child. I will teach you all there is to know of error-bound.
A few studying sessions later.
Thank you, sir. I am more confident than ever about error-bound. I am now on my way.
Hi, kids. Welcome back to the Fun Kids Math Corner. Today we'll be talking about the alternating series estimation theorem. Now what that states is if we have some infinite series, A sub n, some convergent alternating series, A sub n, its remainder, or its approximation, will be equal to its sum minus the nth partial sum, and all that will be less than the n plus first term.
Wow!
I know. So, let's take a look at a series, shall we? Let's say we have the series from n equals 1 to infinity of negative 1 over n over square root of n. And we want to get our remainder, or our error, to correct within 2 decimal places. So what we do is, from this, we replace the remainder with the n plus first term of the series. Replace that with our remainder. Now, since we have the absolute value symbol across all this, we do away with the negative 1. And since we're dealing only with real numbers and we're taking the square root, that will always be positive. So we end up with 1 over square root of n plus 1 less than or equal to 1,000. So now we have 1 over the square root of n plus 1 less than or equal to 1,000. Now, I'm going to skip all the arithmetic stuff, and what we'll end up with is n is greater than or equal to 999,999. So now we have n is greater than or equal to 999,999. So for this, or rather, for this condition to be correct, we'll need to take the most conservative number from our series, the first neglected term. So n will equal the smallest number that we can have so that this condition is satisfied. So n will be equal to 999,999. Okay, so what this tells us is the 999,999th remainder of the 999,999th partial sum will be less than or equal to 1,000th. Pause. So what this theorem tells us is that the remainder of our 999,999th partial sum is less than or equal to 1,000th. or our nth partial sum is less than or equal to our n plus first term of the series. Alright, I think it's time to pass it off to you, Francis.
And now, a word from our sponsors.
Are you okay? Do you need a reason to use your math skills for the benefits of others? Well, you should check out this new thing called Series!
Oh my god! Welcome back to Series and Stuff.
Let this be the fourth degree Taylor. Thank you, Ben. By the way, let this be the fourth degree Taylor for f about x equals 0. Find the error of cosine 0.5 on interval 0 less than or equal to x less than or equal to pi over 4. Well, first thing we should know, it wants the fourth degree of cosine of x over 4, which is just cosine of x. And since it's centered at 0, it is a Maclaurin. And so the cosine of x is approximately 1 minus x squared over 2 factorial plus x to the 4th divided by 4 factorial, since it wants to up to the 4th degree. And so the other thing we want to know is the formula for the error bound, which is absolute value of r of n of x less than or equal to the maximum divided by n plus 1 factorial times the absolute value of x minus a to the next term, like n plus 1. And so we know what x is, we know what the n is, the 4. We know almost everything, we know a is the center, but we just need to find the maximum. And to that, first we need to find the fifth derivative. Since we know that f of x is equal to cosine of x, we know that f to the 5th degree of x is equal to negative sine of x. But if you look on the left side, there will be the explanation. And so what we know is from 0 into pi over 4, if we look at the graph of sine, well, since we have absolute value here, we want the absolute value of this. So that's the value of negative sine of x. It's just sine of x everywhere. If we look at the graph, we can see that it's always positive from 0 to pi over 4, but that pi over 4 will give us the maximum. And so that will be our m. So if we put everything together, we should get r to the 4th degree of 0.5 less than or equal to sine of pi over 4 times divided by 5 factorial times the absolute value of 0.5 to the 5th, which will be sine square root of pi over 4 is square root of 2 over 2, 5 factorial, that's just 120 times this. That's just, you can just change that to 1/2. That would be 1 over 32. Ignore this. These absolute value, I don't know why. And we could rewrite this square root of 2 times 120 times 32, which is equal to square root of 2 divided by 7,680. And that's how you solve for error bounds. And yeah.
That is correct, my child.
And remember, only you can calculate well.
We're rolling.
Oh, my Lord and Savior, teach us the way of error bound, please.
To estimate the series.
Whenever you're ready.
Whenever you're ready, you have the time. Oh, yeah, we are. Okay, good. Alright. Hi, welcome back, kids. Welcome to